All right, so we're going to talk about identity and access management, but I do want to mention I got so excited about machine learning that I wrote some extra credit projects for machine learning, and you can put them in any one of my classes you want. So I put them on my homepage. I now have videos of what demonstrating it last night, but you can practice performing some simple machine learning, fitting curves, and sorting images and breaking a CAPTCHA. And I highly recommend doing this because machine learning is huge, and we should all be able to say we've done some of it. And you understand it a lot better if you've actually done it. So if you're interested, you might do that for extra credit in any of my classes, including this one. However, this class is primarily, of course, CISSP, which is not hands-on, so that kind of thing would not be upon the CISSP exam, so I regard it as an extra thing. So let's talk about identity and access management. Trying to move the slides up. There they go. All right. So there's various authentication methods out there. Of course, the obvious one is something you know, like a password, then something you have, like a smart card, or something you are, like a handprint or a thumbprint, and then, of course, another one is where you are. Can I teach how to trick chatbot moral subroutines? No, I haven't done that yet. I see some articles about it, but I haven't included that yet. It might be interesting to try to include that, but they fixed those, so I haven't gone there yet, but it's a possibility. Anyway, all right. So you can have static passwords or long passwords like sentences, passphrases, one-time passwords, or dynamic passwords. Static passwords are the most common, where you just make up a password and you just keep using it until they make you change it. It's the weakest technique. People tend to choose the same password, and if you get a password dump, you can often find it. So it's better if you do two-factor authentication with the password plus something else. Passphrases are long sentences with punctuation marks. These are considered a lot better, especially if you misspell things or make up an unusual sentence. Not much good if you choose a sentence that is in a popular song or a common book like the Bible or something. That's not very strong because those can be guessed. One-time passwords are what you typically get when you have a new account somewhere. You'll have a password that you can only use once, and the first time you use it, it'll force you to change it. Sort of thing you might get after a password reset attempt. And dynamic passwords. You have a token like these RSA tokens that changes the password every 30 seconds or every time you press a button. And that's fine, but these tokens are expensive. You can also do the same thing with an app on your phone, like the Google Authenticator or the Apple Authenticator or so on. So strong authentication is when you have more than one factor. And they have to be two different factors. So it can't be two things you know. It has to be something you know and something you have, a thing like that. And the question is, how do these sync with the server? And the answer is they are not really random numbers. It's a series of pseudo-random numbers calculated using a pseudo-random function from a seed, and the seed is synchronized with the server. So if they mail you this token, they must have previously registered it with the server, and I don't know how they do that. I know for the apps what happens is when you first sign up to a service like Discord, it'll put up a QC code, and you have to scan it, and that will feed the seed from the server into your app. So now it can generate from that point. And these RSA ones, by the way, apparently had a master key for them all because the Chinese wanted to hack into U.S. military services, I think Raytheon or Lockheed. They wanted to get into Lockheed, and they hacked into RSA, and they apparently stole the master key because after that, RSA did a physical replacement of all the hardware keys of all the companies that were using them. So apparently they were able to steal something from the RSA central servers that compromised all these keys. And that surprised me because logically, if I'm a company like Microsoft and I buy the hardware from RSA, I should be able to synchronize it with my authentication server, and there's no reason for RSA to have knowledge of what the seed is. But apparently they did have a master seed that could be stolen. Of course, that's not been proven because RSA never divulged what the consequences of that hack were. Then all the companies that got replacements had to sign non-disclosure agreements. So there's never been an official statement of exactly what harm was done, but the evidence seems pretty strong that in fact RSA had a master key that could predict all the tokens, and that was stolen and used. Anyway, all right, so people can guess your passwords. Maybe they'll find the password lying around like system logs. The other thing is, of course, is to detect when people are attacking and defend yourself. You can look into logs and see many attempts to log in from the same IP address. And so if you ought to have clipping levels that determine something like more than 5 failed logins per an hour, you'll lock the account either forever or for a period of time like half an hour, which will slow down people that are trying to guess, but it'll let most people get back in. That gives them enough time to go find out where they wrote down their password or something. So storing the password in plain text is a very poor practice, and most operating systems no longer do it, but there are third-party databases that do it. It keeps on happening. It's considered a very bad idea. What you ought to do is store a hashed version of the password, which is not equal to the password. So when people log in, you calculate the hash of what they send you and make sure the hash matches, and that way you don't keep the password permanently on your system. However, you do have the password coming in over HTTPS, and it could, in principle, be stolen from RAM. So it's not as good as the modern system like zero-knowledge proofs. Modern cryptography could actually have you prove that you know the password without sending it to the server, but almost nobody is using systems like that yet. Anyway, so if it's a password hash stored on the system like it should be, then the only way to crack it is to have a long list of guesses, and you hash all of them until you find a hash that matches. So if the hash function is easy to calculate, you can calculate millions of guesses per second and go through a huge list, and a strong password hash prevents that by taking a lot of calculation to hash. So in Unix systems, it's stored in the etc shadow file, the hashes. In Microsoft systems, it's stored in SAM, which is part of the registry, the Security Accounts Manager. Local accounts to log into the machine are in the local system drive on the C drive. Domain count hashes are stored in the domain controller. Hashes are also cached on the local system. So this is a weakness of Microsoft system, making past the hash attacks possible. If you get someone to run malware on a system, you trick them, then you get local ability to run local code. You can look in the cache and find hashes of domain accounts there, perhaps even high privileged domain accounts stored on the local system. And then you can pass that hash to get in. Even if you can't crack the hash, you can just pass the hash over the network to log in. It is a common flaw of Windows systems. So you can strip hashes from network traffic, read them from the RAM with tools like Metasploit, and the SAM file is locked while the operating system is running, but there's a bunch of hacking tools that get past that. Can the sandbox of Windows now to prevent this? I'm not sure what you mean by sandbox. I do know there is a hash passing defense that Microsoft added with recent versions of Windows, but it is not automatic and you have to set it up. But it is possible to make special accounts that can only be used on the domain controller and cannot be used locally, so that the hash is never stored there. I mean, the correct Microsoft, when you read Microsoft certification classes, they tell you you should not log in to a workstation with a domain administrator password. Instead, you should log in with a low privilege password, then right-click and run as on whatever you're trying to do, and put the password in temporarily there, so it only authenticates for that one action. And then the hash is not stored locally. And what the Microsoft hash defense does is it's siloed. Siloed accounts make it impossible to log in on the workstation with that siloed account, so the hash can never be stored there. So if you use the latest version of everything and you set up these siloed accounts, then the hash will not be sitting around on workstations, and that helps to prevent the pass-to-hash attack. But it's not automatic and not simple to set up. So here's some examples of hashes taken from Windows system. All right, I'm just calculating hashes. And one of the things it does, it calculates landman hashes. You see this LM hash here? So if I do password, and here I do password with a capital P, the LM hash here is E52, and the LM hash here is E52. Microsoft's older system, used before Windows XP, is amazingly insecure. It only used the first 14 letters of the password. It changed all the letters to uppercase. It didn't pay attention to the case. It hashed each 7-letter group separately using a very weak routine. So you could actually try them all with products like OffCrack. Microsoft, between Windows XP and later, they switched to the stronger system, Windows NT password hashes, which is only, I think, 1 million times weaker than Linux hashes. The previous system was much weaker than that. Microsoft's password hashing is notoriously, outrageously weak. So a dictionary attack is you attack against any system where you just try a lot of possible passwords. It's fast and efficient, and so the countermeasures are you can have password complexity and length rules to try to choose a password that's not in the dictionary, which is not very effective at all because there are dictionaries of lost passwords, so all the common things people choose to get around those rules are out there. What's far more effective is lockouts to just stop you from trying too many times. So brute force attack in principle tries all possible combinations of characters, but almost nobody does that anymore. almost everybody does dictionary attacks, and they call it a brute force attack. It's sort of a slang term. Rainbow tables are a way of cracking hashes where you store a lookup table that does a lot of the math, so you can very quickly calculate hashes by looking up most of the math from a lookup table instead of having to calculate it over and over. This is effective on the old LM passwords. It's not that effective on modern password attacks. And if you use Hashcat, the main cracking tool, they have a lot of ways to make dictionaries and modify the dictionary, like change some letters to numbers and add numbers to the end and punctuation marks and such, which is the way people do it. And there's DEF CON has a hash cracking contest where people try to crack into hashes, and it's quite a big deal. A lot of people build complex machines with a lot of graphics cards to be efficient at cracking password hashes. Now, if you just run a hash function like MD5 or SHA-1, then if another user has the same password, they'll have the same hash. And that is true of Windows password hashes, but it's not true of Linux password hashes or Mac. They use salting. A salt is where you add a random value to the password before hashing, and then you store the salt in plain text. It's not a secret, but the point is, if two users have the same password, they get different salts, and so the hash does not make it obvious that the two of them have the same password. And this makes rainbow tables almost useless, because you would have to calculate a different set of rainbow tables for every salt value, and that can easily be made impractical. So Windows 10 has password settings. All versions of Windows have these. You can enforce a password history so that people cannot, when they're forced to change their password, they can't use one of their old passwords. And then you can choose the maximum password age. So if they have to change their password by 90 days, you have a minimum password age of 2 days, which means you cannot change it more often than that, to stop people from changing the password around in a circle to get back to their old password. And you can have password length, password complexity requirements, and this option to store passwords using reversible encryption, which is essentially plain text storage and is disabled by default on all modern versions of Windows. That is not recommended at all. It was needed for some old system having to do with MS-DOS or something, and it's available, but only for backward compatibility with old unsafe things. I see a comment from Shu. Hashcat can use the NVIDIA graphics card. That's right. And you can build Hashcat. Yes, absolutely. Hashcat can use graphics cards to make it much faster. All right, so users often write down passwords and put them somewhere unsafe, so it's better to use password managers. All right, and so you can have a synchronous token synchronized with the central server. This is what RSA Secure ID or Google Authenticator does. It just changes every 30 seconds and the server knows what it should change to. You can have an asynchronous dynamic token where you just have to enter a challenge in a pin, or you have to press a button. It's not synchronized, but anyway, the server can tell if you're doing that. So you enter your username, then the system sends you a challenge, you enter the PIN into your little device, and then the challenge plus your password is used to create the response, which is sent to the server. This one's using a PIN and a smart card. All right, then there's something you are, of course, enroll yourself with a fingerprint reader or face scan, and so typically it should not take you more than 2 minutes to enroll, or it's too much hassle and people don't want to use it. And the time to authenticate a user should only be a few seconds. These are the standard numbers you expect, otherwise people won't accept it. And so you can rate a biometric system by the false accept rate or the false reject rate. And down here you have the sensitivity. So if you turn the sensitivity down low, then it will not reject authorized users very often, but it will frequently accept unauthorized users by just working from, say, a blurry picture. If you make it more sensitive, you'll reach the point where the false accept rate is very low, which means an unauthorized user is almost never approved, but now the false reject rate is high, so even authorized users will fail to pass the test because it's too picky. So the quality of the scanner is defined by the crossover error rate. When these two are equal, if you have a very good scanner, then the errors are low at the crossover. If you have a low quality scanner, the errors are high there. And you can choose whether you want to have make it easier to use at the accept some unauthorized people getting in, or hard to use and exclude more unauthorized people. All right, fingerprints are the most common biometric control. I think facial recognition is getting really popular. Now it's on phones. It does not actually store a photograph of your fingerprint. It finds some objects, minutiae. This is also how forensic crime scenes work. They work from minutiae, little points on the fingerprint, like cusps in places where there's a tree sort of branch. They find little details and store those, like this. This is where something hits a peak. This is where something splits. Here's where something splits into 3. They find these points and memorize those. That's what they're looking for. All right. One thing I've noticed, most people love the fingerprint reader on the Mac. It never works for me. Every time I train a Mac on my fingerprint, it works for about a week and then it quits working. My fingers are apparently no good. I also can't wear Apple earbuds. They just fall out of my ears. I appear to be a non-standard human. Anyway, all right, so retina scan. You have to stick your eye in a holder and shine a light right in, and then it can read the back of your eye. And that is very accurate, but most people find it unpleasant to stick their head in some kind of holder and stick their eye right up next to a camera. People don't like that, but it is quite accurate. An iris scan is much simpler. This is where you just take a photograph of you and they look at the colored part of your eye, which is on the outside. And this you can do with a high-resolution picture. You can even do this in like an airport from a camera up on the wall. It can look to iris matches of people that go by, and the pattern of colors on the iris is very individual. So this is considered high accuracy and being deployed at sporting events and such to detect people who are on known lists of terrorists and do not fly lists and such. And hand geometry measures the shape of your hand. And this, I think, is what Amazon is using. I tried one years ago at RSA, and they just have a little plastic thing you put your hand in about 4 inches above a camera, and it measures something about your hand. I think just your hand geometry. I'm not sure. Something about your hand that it finds unique. Then you can measure how people type, measure all sorts of details of the key presses, and try to identify them from that. I've seen people talk about this. I've never seen it deployed. I wonder if it's really accurate enough. And then you can sign with a pen, and again, it can notice the way you make motions and in principle decide if it's really you. I've seen these things deployed to tell if you're a human and not a robot, but I haven't seen them as an authentication scheme. And voice print too. Voice print's been in science fiction for 60 years. Turns out to be much less effective than people thought. I think because people get colds and their voice changes, and it's hard to find the real unique part of it. And face scan is getting very popular. Most laptops, many cell phones have facial recognition now. And that you can use for authentication. It seems to work fine on my iPhone. Law enforcement and security agencies have tried to use it, and they've had huge problems, and many large companies have abandoned facial recognition, like Microsoft, because when deployed by police, it tends to be extremely ineffective. One of the huge problems is they tend to be very, very bad at recognizing black people, and only recognize white people, which probably because they're only trained on white people. But anyway, they did things like that, which are very dangerous legally. So anyway, people are using it, but it turned out to be quite fraught. And so using some clue of where you are is quite helpful, where you find your GPS or IP address, and then you can make sure you're really in the right location. And there is some new system I've seen in the news that we're all supposed to be switching to, where you use a phone. The phone will do a biometric identification of you, and then use Bluetooth to verify that the phone is in fact right near the machine that's logging in, and then log in from there. And this, they say, will totally defeat man-in-the-middle attacks. Nobody in the middle will be able to pass this test, that the device logging in has to be physically near your phone, and the phone has to biometrically verify that it's you. So that's a new login system that we all should be switching to, but it's not out there yet, not to any significant amount. All right, let's take a look at a Kahoot. I don't remember the name of that new one, and it won't be on the CISSP exam yet, I think, but it was in the news about a month ago. yes, yeah, if you attend the RSA conference, that's worth extra credit. And by the way, there's a student day. I think I just put that on my page. Let me, yep, College Day Thursday. If you click this link on my page, it'll get you where you can apply for a free day. Yeah, that's worth extra credit, absolutely. Any kind of conference like that is. Are you still coming in? You're not coming in? Okay, fair enough. All right. All right. This is not the right one. Absolutely not the right one. All right. 125. Let's try this one. All right. Bees, all right. Well, they might be mosquitoes, so it's a little hard to see. Yeah, I guess they are mosquitoes. Okay, good. All right, looks like we got everybody that's coming. All right, so what biometric system denies entry to authorized users? All right, that's high false reject rate. That's what it is. False reject is when you deny entry to authorized users. False accept rate is when you're letting in people that are not authorized. All right, where are the password hashes on Windows? In the SAM file. The shadow file is Linux. In Windows, it's the SAM file, which is part of the registry. All right, what would you add to a password to make two-factor authentication? Face recognition is what it would have to be. You can't have two things you know. All these are things you know. Two things you know is still one factor. You have to have a different kind of identification, like face recognition. Biometrics plus something you know would be two factors. All right, what stops an online brute force attack? Yep, locking out after too many guesses is what stops that. All right, and what's the weakest password hash on this list? Yep, the old Microsoft one. LM is so weak, even Microsoft won't use it anymore. NTLM is the current Microsoft one. SHA-1 is stronger than that, and Linux is a million times stronger than that. All right. All right, ding it. All right. All right. So, access control technologies. One thing you need is central access control. If you have a bunch of computers and they're not connected to each other in any way, just connected to the internet, then each of them has their own password, and that's okay for like individual machines, but at a company, you need to have a central point for access control. Then you can have one authentication system that lets people log on. Someone wants the link to sign up for RSA. Let me put it in the chat. It's here. All right. Anyway, so now you have one central point. Then you can control the passwords in one place. This is why you need a domain controller for companies typically. And it's a single sign-on. She asked how many points. Oh, probably like 20 points if you go there for the day, I guess. Something like that. Anyway, so this will give you a single sign-on where one authentication allows access to multiple systems, which is really important. Otherwise, you have to keep logging in again and again. And then centrally, you provide the AAA services, which is authentication, authorization, and accountability. Authentication is verifying who you are. Authorization is deciding what you're allowed to do. And accountability is keeping logs of what you did so they can be reviewed later. And you typically want all three of those on a central server. Now, decentralized access control is where you have independent systems at local sites. Then your sites are independent. The problem is they might not all obey the security policy, and attackers might find the weakest link. So this is not commonly done. Most people use something like Windows domain controllers, and they really synchronize them everywhere, so all the locations of your company use the same domain controller data. They might have a local image of the domain controller just to log in faster, but it's going to have a copy of the same data as the main domain controller. So single sign-on is where you sign in to one machine, and then that gives you access to many systems, which is what you have at most companies. The problem, of course, is if someone can defeat the single sign-on system, then they can get into all the systems, but usually the convenience is so big for the users that you don't make your users log in more than once per day. All right, and so now you got an issue of session management, which is the problem when Microsoft passed the hash attack. You sign in once, now you must issue to the user some kind of token, which they use to access other systems, and that means if someone can steal or predict that token, they can get on the other systems without logging in. And that's what happens with Microsoft. They use the hash of the password as a token, and that's why you can use a pass-the-hash attack to get into an account without cracking it. All right, it also means if an attacker can take over a system that's not in use, then they could get in. So you have session timeouts and locking screensavers, and there's companies where they will fire you if you walk away from your machine and you didn't lock it because they don't want anybody using machines. Link is broken. What? All right, let me take a look. I thought I tested it. Oh, All right, I guess I got a typo in it. That's rude. All right, I'll have to look at it when I get home. Is that okay. Oh, I forgot to upload it. That's right. Thanks for telling me. I'll have to upload it when I get home. I put the link here, but I forgot to upload it. Sorry about that. All right. So, so you have to, this is called access provisioning, when you give people access to get into your systems, and then you deal with the changes, like when they quit or when they get fired, you have to take that away. So people mostly force you to change your password every 30 or 90 days, which is in fact a really bad idea, but it was recommended by the government until a few years ago, and most companies have not learned the new rule. So you notify users when the password is going to expire. You do something about inactive passwords or unused accounts. The most important thing is to revoke access rights when people don't work there anymore. It's very common that people leave old accounts active, and then those people come back or they get compromised. So you have to coordinate your account revocation with your human resources and have a termination process and consider other moves. And people move to different roles in the company. You have to efficiently remove their access to the things they're not supposed to have access to anymore. Many companies do not organize this properly. For example, the college. The college here just issues you more keys every time you go to a room, and they never collect the old keys. So the older a teacher is, the more keys they have, which is, in the physical level, the same kind of thing a lot of companies do. Because they just think about getting the job done, and they don't think about abuse of the system. All right, so access aggregation is what I just described, where the more longer you've been at a company, you just have more and more access to things. Authorization creep is similar, where you gain more entitlement without shedding the old ones. And this, of course, can result in defeating security privileges like least privilege and separation of duties, where you have the ability to act in several different roles. So you're supposed to audit these things, audit what people are allowed to do, and see if people have privileges that they don't need anymore. Federated identity management is where you log into one company and some other company trusts that login. So you trust somebody else to log in for you. In practice, for example, Facebook seems to be the world's identity. Almost every website has an option, log in with Facebook. And now it often has log in with Microsoft or log in with Google. So you trust Microsoft or Google or somebody to handle the password, and they tell you, okay, this person logged in, here's their name and their email address and whatever else, and you just trust that. So that's called federated identity management. Obama tried to make the government into the trusted federated identity management. He thought it was a problem that people had to know all these passwords, and he wanted the government to take over. Nobody went for that, but they all seem to go for Facebook doing it. So security assertion markup language is used for exchanging authentication data over the internet. Canvas uses it, and so it's an XML-based framework where you have a big cryptographic token that you send up to the server, and it sends you back a big cryptographic blob of data, and that proves that you have proven who you are. You can then send that to the third-party provider. So identity as a service is what we're describing here, where you have some kind of cloud identity. For example, Microsoft had one called Live ID and Microsoft accounts, where you log into Microsoft, they give you a token, and now you can connect any service to the Microsoft account, just sort of like log in with Facebook. And therefore it'd be easier to deploy two-factor authentication. This happened about a year ago. There was, I think it was Okta, was a cloud identity provider. Many people used it to get two-factor, and then Okta got hacked. So all these companies were compromised. So that's, of course, the risk if you trust a third party. If they get hacked, then you're hosed. Is ID.me such an SSO function from the federal government? Well, I don't know. Let's see what ID.me is. I think I've heard of ID.me, but I don't really know anything about it. This does not look like a government thing. It says you can access your government services, though. Oh, Social Security. Well, I don't know. Maybe it is. Maybe this is the government. It's a good question. I know the Obama one never happened, but maybe this is some attempt to do the same thing. ID.me government. ID.me shop. This looks like a third-party thing, not the government, but I'm only guessing. It's a good question. I don't know. All right. So then you got your password managers, another credential management system. Credential managers are really important. Everybody should use them. Then it can generate random passwords. And the most important thing is now you use a different password at every site. And well, if you don't use a password manager, most people use the same password at many sites. And that's a very bad idea because sites keep getting hacked all the time. And by the way, in the news today, they surveyed people, and 70% of American IT managers admitted that they got hacked and they did not report it to the government and concealed it. And they had been ordered to do that by their company. So a lot of companies get hacked and they never report it, and you never know. So even though you see all the news about breaches, you should multiply that by something like 4 for how many breaches are out there. So using the same password at multiple sites, that's the risk. If any one of them gets hacked, then they can get in all those other accounts. So it's better to use a password manager so you have a different password at every site. All right. So you can host a third-party ID service locally. This is something you could do. You could have your own identity provider as part of your company. That's another option. Make your own private cloud identity. And LDAP is a protocol used to send identity information across a network, and this is what Active Directory uses, Microsoft system. An older version used plain text transmission. There's a later version that's encrypted. Kerberos is also used by Microsoft Active Directory. This is a system developed at MIT to avoid sending passwords in plain text over the network, And so it uses both symmetric encryption and mutual authentication, and it's quite complicated. There is a ticket granting service. You apply, it sends you an authentication ticket, which gives you the right to access something for just 10 hours, and so on. It's got a lot of encrypted stuff flying around, but it does avoid sending your password in plain text. Yeah, here's some of the components. The principal is the client trying to connect. The realm is the network. The ticket identifies the principal. Your credentials are a ticket and a service key. You get that from a key distribution center, a ticket granting service, and you have something called a ticket granting ticket. It's quite complicated, but a lot of these things flying around. And by the way, there are attacks where you decrypt these things and extract the password from them. So they are like password hashes, but they're more complicated than password hashes. Yeah, so your principal contacts the key distribution center. They then send you a session key encrypted with your secret key and a ticket granting ticket. Then you decrypt the session key and you go to the ticket granting service to try to get a ticket to access something. It verifies your session key and sends you a second session key and then a service ticket. Now you connect and you can use something like a printer. So seems ridiculously complicated, but that's what people are really using. And there's a diagram of all the 5 steps. You wish to authenticate, you get a session key, you go to the ticket granting server and get a ticket, then you send the ticket to go to the printer. All right. The ticket granting lifetime is typically 10 hours, and all your machines have to be synchronized within 5 minutes or it will reject things. That should be off. A lot of typos in my slides. All right. So the key distribution center has all the keys, and that would expose them all. There are single points of failure. If either one of these servers goes down, the system stops working. You can replay attacks. The network transmissions do not have a random thing added to them to prevent them from being replayed, and old versions had a way you could impersonate another user. And anyway, and the keys are in the RAM on the machine, just like passwords and most things. So if you have access to a client's RAM, you can steal them. So, it has some weaknesses, but it's better than sending plain text passwords over the network. Sesame is a European system to do essentially the same thing. Most important thing being it has public key encryption, so you don't have plain text storage of symmetric keys. I've never heard of anybody using Sesame, but maybe they're using it in Europe. Now, Radius is a really old system, still used by a lot of things, so old you can see the name, for dial-in user. It dates from the days of dial-in modems, and this is a AAA server. So it would perform authorization, accounting, and access. And so you send it names and passwords or other credentials, and it has a database and verifies them. The diameter is the improvement of it to be using TCP instead of UDP, and is considered the upgrade from Radius. A lot of people are still using Radius servers. TakeX was a Cisco proprietary one, I think, and TakeX Plus is an improvement of it. This is another competitor that does the same thing, encrypting all the data, whereas Radius only encrypted the passwords and so on. Just another way to make a AAA server for authentication. In the really early days, you used PAP. PAP is where you send plain text passwords over the network, like Telnet and FTP. That's ridiculous, of course, but that was the first system. So the next step up was CHAP, Challenge Handshake. The server would send you a challenge. You add the challenge, which is a few letters to your password. You hash that and send that over the network to prove that you know the password, and therefore it's a little bit harder to steal the password off the wire. And Microsoft uses MS CHAP version 2 now. But Microsoft Active Directory domains now group your people into domains and uses Kerberos. Your domains can have trust relationships, which is what happens when one company makes a partnership with another. So if you are Kmart and you buy Target, you can then say all the Target employees can log in with Kmart credentials, but the Kmart credentials cannot log in with Target credentials. That would be a one-way trust relationship, or you can have a two-way trust relationship, or you can have a transitive trust where you trust the company and you trust anybody that company trusts. So you can arrange all these different levels of trust. And this is really important for big business, and it's a lot of the reason why big businesses all use Windows machines. If you use Linux, none of this is available. And now when you want to do something like acquire another company or have a business relationship where a whole bunch of employees from another company have access to a certain part of your company for 6 months or something, that's much harder to do. Microsoft domains have all these features built in, so you can do these big business operations cleanly and successfully. All right, so then there's access control modes. Discretionary access control is the weakest. Mandatory access control is the strongest, and we'll talk about non-discretionary. So discretionary access control is the simple one. It applies to like a home laptop. You have the object, and you can do anything with it because you own it. So like you're the administrator of your laptop, so you can share any files or any functionality of that laptop with anybody else. That's discretionary access control. Then there's mandatory access control, which is the most secure, where you are in some kind of controlled environment like the military. So subjects have clearance, objects have labels like confidential, secret, and top secret, and therefore only people with top secret clearance can access the top secret materials, and you can only move something from one level to another by going through a declassification process. So it's expensive and complicated, but much more secure. Non-discretionary access control is where you don't have discretion. So, for example, role-based access control, which is essentially what Windows domains are. In companies, you are sorted into a category like manager, help desk, sales, or whatever. And once you're in that group, you have the permissions of that group. And you can't move to another group without being reviewed by upper management. That's role-based access control. And a similar one is task-based access control, where you're sorted into what task you're doing and given whatever access you need for that. All right, and so you have roles like nurse, backup administrator, help desk technician, and you have access to different things depending on what you need to do that job. This is what companies use typically with domain controllers. And task-based access control is essentially the same thing. That should be a tape. All right. And rule-based access control is where you have some kind of rule, just any kind of logical rule you want, like firewall rules, certain kind of data can get through. One type of rule is time limitations. Many people only let you log in at certain times, like only between 9 and 5, you're not supposed to log in after hours, that sort of thing. And so you can add other kinds of access control, like content-dependent additional criteria, like you can only see your HR data but not someone else's data, context dependent, like you can only get in from certain times of day or only from a certain location. These are other limitations which, of course, increase security by preventing hackers from getting in from unusual places. So let's try the other Kahoot. All right. A few more seconds. All right. All right. So what does AAA stand for? Accounting. I guess they call it accountability here, but the point is that's keeping a log of what you do. All right. All right. What's SSO and internet scale? Yeah, the best answer is SAML. That's what's straight from the slides. LDAP and Kerberos are used inside Windows domains and not at internet scale. And identity as a service might be part of it, but it's not clear. And this is the answer recommended by the slides anyway. And this, you could argue this is a good answer, but like I say, this is the kind of unfairness you get a lot of on the CISSP exam. Anyway, SAML, Security Assertion Markup Language, is used for this. All right. And log on with Google. What does that provide? That is federated identity management. It is not single sign-on. Now, single sign-on would mean you log in here and you can access many services, and that might not be true. Logging on here might only give you access to one service, but it's federated identity management. It means you're trusting some other company to handle the identity and believing it. That's what those logon do. All right. All right. In Kerberos, what is the workstation logging in? What do they call it? That's called the principal. By the way, another fun fact about Kerberos is there is a thing called the golden ticket, which is created when you first elevate a machine to a domain controller, and that golden ticket is good for 25 years. And if you get the hacking tool Mimikatz, it can steal the golden ticket. And if you steal the golden ticket, there is no way to change it. You have to recreate the entire domain for the company to get a new golden ticket. So it's a really devastating attack. Anyway, the log workstation is called the principal. All right, so what access control model do you have on your home laptop? It's discretionary access control. If you join a Windows domain, it would then be role-based, and if you join the military, it would then be mandatory. All right. But if it's just your laptop, then it's discretionary access control. You own it, and you can do whatever you want with it at your discretion. All right. I've got those recorded. All right, and so what the golden ticket is used for is to identify the domain controller, the center of all the trust, and all those other things like the ticket granting service and the ticket granting tickets are all authenticated to the golden ticket, which is the root of trust for the whole system. That's why it's created when you first make a domain controller, and it's never changed for 25 years. And that's why this tool, Mimikatz, if you don't know about it, is pretty fun. This is a New Zealand researcher that keeps writing this tool called Mimikatz, and he is incredibly effective. And every time Microsoft keeps updating Windows to stop it, and within 3 days he will update Mimikatz to get in again. This tool is amazingly powerful and constantly updated at defending. Primarily, what it does is attack Kerberos. He keeps on finding weaknesses in Kerberos and ways to break in. This is very commonly used. So every endpoint protection tool will try to detect Mimikatz and block people running it because it's a really powerful hacking tool, and they don't want you to run it. Why this happens if MIT's Kerberos is open source? Well, this is apparently the way Kerberos is designed. It has some root of trust, and I don't think Microsoft's implementation of Kerberos is open source. I think just the fundamental protocol is open source, and I think Microsoft has details they keep adding and updating with all their patches. And he keeps on finding flaws in the way Microsoft handles Kerberos, and they keep patching it, and he just keeps finding more flaws. It's been going on for years. All right, I'm going to stop this recording.